Thank you, sir. Good evening, everyone. On behalf of Dharampet MP Memorial Science College, Nagpur, and NASNI, I, Dr. Shraddha Joshi, warmly welcome you all to the 18th NASNI talk. Today, we have gathered to explore a fascinating subject, astrophotography in city light, a blend of science, art, and technology that reveals the hidden beauty of our universe, even amidst the glow of urban life. We are truly honored to have with us distinguished personalities. We have our esteemed speaker, Mr. Victor Chakraborty, a passionate explorer of the skies and a dedicated astrophotographer. We also have Professor Hemant Kumar, the coordinator of the NASNI, whose constant encouragement and vision keeps inspiring young learners. We are having head of the Department of Physics, the MP Memorial Science College, Captain Professor Prashant Ambikar sir with us, and all the other friends. I warmly welcome you for this talk. Friends, we often believe that city lights overpower the beauty of the night sky. Yet, with the right knowledge, patience, and technique, astrophotography allows us to capture the wonders of stars, planets, and galaxies, even from urban settings. Tonight talk will open new horizon for all the sky enthusiasts. Now let me take a moment to introduce the star of today's program, astronomer Victor Chakraborty. Victor, Victor Chakraborty is not only a passionate astrophotographer but also an official registered space tutor of ISRO. He is a co-founder and director of Astrasitara Astronomical Observatory and has been actively leading innovation initiatives to make astronomy accessible to all. He is also associated with Konagar Space Lab, a unique citizen science project in collaboration with NASA and Penn started in 2024. Alongside his astronomical contribution, he is the chief editor of Noble Erudite, an education startup project. Victor Sir has been deeply engaged in education and social cause. He has served as education coordinator at South Kolkata Humri Muskan and worked as project implementation officer at Garia Change of View Society and program manager at Kolkata Rista under NACO targeted invention project. He also contributed as a market research analyst in IMRB International. His contributions have been recognized with several prestigious awards, including Rabindranath Tagore Hall of Fame Award for Excellence Contribution into Education, Gaur Gopal Chaudhary Award for Educators, and his talent in astrophotography has earned him global recognition, being featured as Astrophotography of the Day by Armature Astronomers Association and Astrophotography of the Month by Orbital Today magazine, United Kingdom. Truly, he is a rare combination of educator, innovator, and science explorer. Friend, please join me in giving a warm welcome to our keynote speaker, Mr. Victor Chakravarty. Over to you, sir.
Thank you, everyone, for this wonderful opportunity, and thank you, Miss Shraddha ma'am, for this wonderful introduction. I'm really honored to be part of this. And if I begin my journey with astrophotography and astronomy, I was always very much interested in astronomy since my childhood. But actually, what happened was, generally, for a very middle class family, it's not always affordable to go with any kind of astronomy educations. So after I got my job in Kolkata, I started going a little bit deeper into this subjects, and I started studying more and more about science. Did my BSc honors, BSc in physics honors actually, and then I decided this that while I do my studies and everything, I should also pursue my dream of astronomy again. So basically, from the city skies, I basically started with a very small 50 telescope. You might have seen many times, like many of you might have also used it. Celestron 50 telescope, which is a very small one. And with that, you will only be able to see the moon. But that moon was my first fascination towards going more deeper and deeper into this subject. Much later, I realized one more important thing. It was this, that whenever I tried to talk about astrophotography or astronomy with anyone, the only thing that always came to me from everyone's response was, we need a dark sky. We need a dark sky. The point is, it's not always affordable for everyone to go to a very dark sky location. There are many dark sky sites like the one in Hanle, the other one in Ladakh. There are many places where you can go and do absolutely wonderful astrophotography from there. But the point is, it's not accessible and affordable by everyone. So this came to my mind. So that why not we start astrophotography and astronomy from the city areas? Because what happens is, when we start doing something like that, we will see this, that even the local people, the common people, for whom going to Ladakh may not be always very much possible, even though they can also come and enjoy the night sky with us. So we started Astra Sitara. The basic concept of Astra Sitara was this, that we want to make astronomy accessible for everyone. We have to make it like this, that we are bringing the stars to your doorstep. So this presentation that I have made for every one of you, this is basically a brief, a very small description on how you can start doing astrophotography and astronomical observations from the city skies. You will definitely need a few things for that, but the most important thing always will come with your own patience. Remember, this takes a little time, because the first thing you have to do is adapt to the environment around you. So, with that being said, I'll start my presentation now. So, why stargazing is so important in today's world? A few months back, BBC magazine, they published an article where they wrote about stargazing and the importance of it today. The first thing it does is, whenever you are looking into the stars, whenever you are looking into the night sky, the first beautiful thing that happens is it reduces your stress. Because when you are looking up into the night sky, you suddenly start feeling like this, that you're part of something so grand and so cosmic. And that often helps you in reducing your own stress levels. It always gives you a feeling of happiness. When you look into the stars, when you look into the night sky, it gives a feeling of something achievement from inside. And that always brings happiness. So, this is why we always say this, that for kids and for everyone, stargazing is for everyone today. Stargazing doesn't need an age. Even a kid or 5 year old kid to someone who is 70 or 80 years old, everyone can do stargazing, and everyone will feel that happiness when they do that. Third is, it connects you with the nature. One of the important thing that has happened today is this, that we have missed the concept of sustainable development. We have done a lot of development, we have modernized everything, but we have somewhere lost our connection with the nature. When you are doing stargazing, it often brings you close to the nature. It brings your connection with the nature back, and this often helps you to feel better about yourself. It boosts creativity. We always believe this, that while critical thinking is necessary, but with that, creative thinking is also something which is necessary. You will see this, that whenever we did any kind of shows, public shows, a lot of kids came to those public shows. And the most common question that was asked to me always by kids of 6 or 7 years of age, or someone of 10 years or 12 years of age, the most common questions that I always got from the kids was this: are we alone in this universe? Are there any kind of aliens? That's the first question. And we always got the second question, which was always related to the topics of astronomy, which was like, they often asked, what is black hole and what exactly is it? So you see, when you explain those concepts of black hole to a very small kid, they won't understand the every detailed stuffs about black hole. Maybe we won't be able to explain them very properly about the singularity in there, But when we do something like that, when we try to explain black hole in a very simple concepts with them, it boosts the imagination in their minds. It boosts their imagination. It boosts their confidence and their storytelling abilities also. And this is something that we have often seen with the kids. They will often ask this kind of questions. They will often want to know about if aliens actually exist and how they might look like. And we let the kids explore those options. We let them think how aliens may look like. Many times, what we have done is, while having a public show, we have also given them a paper and a few colors, and we told them that draw your own alien, draw something of your own. This boosts a very beautiful amount of creativity in the children. It promotes calmness and peace. Always, whenever we are doing stargazing, it promotes a beautiful feeling of calmness and peace inside ourselves. And that is, these are some of the very important reasons why everyone should do stargazing in modern world today. Now, coming to my second stop with this, second side with this, like what do we need to do for doing stargazing from the city? See, city skies are extremely polluted. Light pollution is very much there in cities. And especially when you're looking into cities like Kolkata, Delhi, Mumbai, these kind of cities have extreme amount of light pollution. So the first thing that you need to do is look up the night sky and try to take 5 minutes time and just look blankly into the night sky. What happens is your eyes slowly starts adapting to that darkness. And when your eyes start slowly adapting to that darkness, slowly you will see this that you will be able to stars and the planets that will be very faintly visible, but you will be able to see that. So the first thing that we always do is this: we tell people to first adapt their eyes to the darkness of the sky. And for that, you need to have 5 minutes and just look into the night sky. Second is having stargazing apps like Stellarium, Sky Atlas. This is very important because for most of the people, they might not know about the constellation. Astronomers, we are very much habituated doing this daily. So we know where the constellations are. We know where which star is, where which star is. But the common person who hasn't been doing this for a long time, they will not themselves. Third thing, we always say this that you should do stargazing after midnight, if possible. It's switched off. So as a result, the light pollution decreases a little bit. Stargazing conditions becomes a little bit better for stargazing that time. Fourth is look for men here. Omega, these are very easily visible. Even Cassiopeia is very much visible, even from the city lights. You will be able to see these constellations very properly without much hesitations. Just in a little, just if you get a proper clear night sky from the city skies, also, you will be able to get Orion, you will be able to get Auriga, you will be able to get Cassiopeia. These are the constellations that you can easily see. Other than that, sometimes if your luck is very good, you might get clear skies from the city lights also, from the city areas also, where you will be able to see a star cluster called Pleiades. Just a little bit uh, towards the eastern side of the Taurus constellation, there is a very beautiful star cluster called Pleiades. And this Pleiades is very much visible. It's a very much visible one from the city skies. There is also one another star cluster that you can also see from the city lights, and that is what we call as the star cluster called IC36, which is present in the Scorpion region. These kind of star clusters are visible from the city lights with just the help of your phone. With just your phone, you can capture them. You can also, with your phone, you can also capture things like binary stars. Many binary stars like Alcor and Mizar, the one that is found in the Big Dipper, the asterism called Big Dipper, which looks like what we also call as Saptarishi, the seven stars together, looks like a spoon kind of a shape. That asterism, in that asterism, there is a star called Alcor and Mizar. And this Alcor and Mizar is a binary star. And this binary star is also visible in your phone if you take a photograph from the city skies. You will be able to see this binary. So there are many possibilities. All we have to do is we have to learn like how to use it. And if we know how to use our phone for doing astrophotography, we will be able to do it. I'm saying it won't be as good as something that you can get from a bottle one clear night sky, completely dark skies. I know you won't be able to get something like that, but the point is that it's better to have something than nothing. And from the city skies, this kind of astrophotography is absolutely possible, and we often do that. The next thing that you have to do is use timer and keep the phone stable. You have to use a timer and you have to keep the phone very much stable for taking a photograph of the night sky. Because if the camera is shaking a bit, what it will cause is it will not be able to give you a proper view of the night sky. And the shutter speed when you're taking the photo should be around 13 to 15 seconds. If you're going more than 13 to 15 seconds in the city sky, it will become too bright. And if you're keeping the shutter speed around 13 to 15 seconds in your phone, then you will get a proper night sky in your phone. You will get the proper view of the constellations and of the stars. Wherever we are trying to photograph the moon from our phone, the most important thing that we have to do is we have to reduce the brightness. Moon is extremely bright, and to reduce that brightness and reduce the shutter speed, you will be able to take the picture of the moon. Uh, One of the most common misconception that we often find, people like to come and watch moon in our telescope on full moon days, but we often tell them that full moon is not good for lunar observations at all. The reason is during the full moon, moon becomes so bright that it becomes absolutely impossible for people to see the night sky. It becomes absolutely impossible for people to see the craters and the different areas of the moon. Generally, when the moon is at its 60% or at its 50%, something like that, you will be able to see the craters. You will be able to see the various mountains of the moon. But when it is not, like when it's full moon, it becomes a absolute, it becomes so bright that you won't be able to see any features of the moon at all. But again, this is basically a misconception that often occurs among people who doesn't have the idea that how we can use a telescope for this. Okay, now white balance can depend upon you. For people, many people will want a photograph where they want a little bit of a bluish tinge. Someone will want a blackish tinge of the whole night sky. So the white balance often depends upon yourself. Like whatever way you want the photo, it is basically your own creative freedom to do that. So generally, whenever we are doing astrophotography with phone, these are some of the things that you have to remember for doing astrophotography from the city skies. Now, after this comes the next slide. What telescopes are suitable for city conditions? We are often getting asked this kind of questions like, what telescope should I buy? The first thing that I will always tell everyone, don't buy anything from Amazon. Amazon or any kind of e-commerce sites, they will often have those kind of telescopes with very glossy pictures with stuffs written like 625x magnification. Please avoid those kind of stuffs because these doesn't work that well. Whenever we are going with telescope, a few things has to be remembered when you are buying a telescope in a city sky. First thing is it should better it will be if you can get a Dobsonian scope. And Dobsonian scopes are very easy to use And a 8-inch or a 12-inch Dobson will give you a very proper view of the planets. You can see the planets like Venus, Mars, Jupiter, Saturn very properly with a Dobsonian scope. Other than that, you can also see Orion Nebula and various other star clusters also. Star clusters like M41, M47, these are very well visible with a Dobsonian scope, even from a city sky. Then another thing that I have often told people is avoid red dot finder telescopes. Many of the telescopes, like especially in today's world, many of the celestron telescopes have this kind of finder scope called red dot viewfinder. Red dot viewfinder are absolutely disastrous when you are using it in a city sky. The reason is because it doesn't work that well and nothing is visible with that. In a city sky, the sky is already illuminated. It's already extremely bright. And in there, if you don't use a proper magnified kind of a finder scope, you won't be able to see anything at all. You won't be able to find anything at all. The major function of the finder scope is basically to find the target that you want to see. And if you are not able to find the target, you won't be able to use your telescope at all. And red dot viewfinder doesn't help in that. What we often tell people is to attach a 6 into 50 or 8 into 50 finder scope. A 6 into 50 or 8 into 50 visual finder scope, what it does is it will magnify the image and you will be able to see it properly. And with that, you will be able to find your target properly with that. So that is why we often tell them that the finder scope should always, finder scope like red dot viewfinder should always be avoided. A red dot viewfinder is absolutely useless in the city skies. In the city skies, it will give you nothing at all. You won't be able to use your telescope with that. Another point that we always say is if you have a telescope, collimate every week. Especially in city locations, you have to collimate your telescope every week. Collimation is needed to get proper clarity because when you're collimating your telescope often, you will be getting much more crystal clear images. And for that, collimation is very much necessary. And we often collimate our telescope in every week, or if not possible every week, then every at least in 15 days, we collimate our telescopes. Because otherwise, it becomes very hazy. And we slowly see this that the images starts getting a little bit blurry after that. One thing that we in Astrositara often use now for astrophotography is telescopes which are smart telescopes. Smart telescopes, like one of the thing is ZWO C star S50, C star S50, C star S30, and Dwarf 2. These are smart telescopes that are not very expensive compared to the traditional astrophotography gears. Like a traditional astrophotography gear will cost you something like 3 lakh to 4 lakh rupees. But a C star telescope, a smart telescope, will come handy at around 50,000. So it is much more affordable. So when you're using a smart telescope, it's very, very much good to use in city sky areas because with a smart telescope, you can do absolutely wonderful astrophotography. Later on in this presentation, I will be showing you some of our astrophotography and some of the scientific facts with it, like what we have seen in those photographs and everything. So these are some of the things, like some of the telescopes that you can use when you are doing night sky observation from the city lights areas. After this is what the light pollution index is. The word for this is what we call as the bottle. Bottle 1 is basically the most clear night sky that you can get. In today's modern world, bottle 1 night sky is rarely available. There are very, very few places in this in our country today where the bottle 1 night sky is available. Bottle 2, bottle 3 is also very rarely available. And very less places you will get skies like that. Those skies are absolutely pollution free night skies. And from there you can see everything. You can see absolutely wonderful amount of stars and everything from those kind of night skies. When we come to bottle 4 and bottle 5, these are basically suburban skies. Like when you're living a big city, like big multi-city, and you're going to a little bit of the suburban areas, there you will get skies which are bottle 4 or bottle 5 skies. In bottle 4 and bottle 5 skies, what happens is you will be able to see night sky much better compared to the extreme city skies. In the city skies, what you will be able to see in bottle 3 or 4, you will get a much better view than that. Bottle 2 skies is sorry, bottle 7 sky is what we get generally in those areas where it's just at the outskirt of the city. In the outskirt of the city, if you go, the pollution is little less compared to the main city areas. And from there, you will get a bottle 7 or a bottle 8 kind of sky. And the last stands is bottle 9. Bottle 9 is the absolute city sky. Like you can say this that at this is the sky that you get at the main point of the city, like at the city center. That's the basic night sky that you get from there. Bottle 8 and bottle 9 night sky is extremely illuminated, and from there, stargazing, it has its own limitations. I won't say that it is impossible, but I will say that it has its limitations from there. Like there will be only limited amount of things that you will be able to see from there. Like right now, our observatory is placed in bottle between bottle 8 and bottle 9. And from there, we are able to do various kind of astrophotography. And we are able to see planets like Jupiter, Venus, Saturn regularly in our telescopes. Now, coming after this, I will now slowly move towards some of our astrophotography that we have done. This is the most famous Whirlpool galaxy, and this is the image that we took in our smartphone. I mean, in our smart telescope. Um, if you see this image, you can see the spiral arms of the galaxy very well. These are the Whirlpool galaxy is a spiral galaxy just like our Milky Way, but it has a partner with it, a partner galaxy with which it is gravitationally interacting. That partner galaxy's name is NGC 5195. Now, there is a very wonderful thing you will be able to see in this. You can see that the arm structure of the galaxy, of the main Whirlpool galaxy, you can see it's a little bit distorted. The arm is little bit distorted because of the gravitational interaction with its smaller partner. That gravitational interaction is slowly distorting its arm into a different shape. But what is also happening is these are the most starboard area of this galaxy. Like what happens, the gravitational interaction causes the gas clouds, the hydrogen gas clouds in there to compress and combine together. And when they are compressing, they are forming a protostar from there. And the moment they form a protostar with that, a nuclear fusion is happening, a nuclear reaction begins, and the star formation starts. So that gravitational interaction is boosting a rapid amount of star formation in this galaxy. This galaxy is 31 million light years away from us. That MLY stands for million light years. So you can just see this that the light that we are getting in this image that came 31 million years ago. So that is how far it is from us. So this is one of the picture. This was I think I took this picture last year in 2024. I took this picture I think around in September or October that time. This is a binary star that you're seeing. Its name is Mintaka. This is the binary star. If you just zoom the image, you will see this. Like, wait, I'll zoom it a little bit. Like, if you can see this image, you can see the binary partner of the star. It is basically looking like two stars together, but in reality, it's basically a six-star system. There are six stars. The giant one that you are seeing It consists of basically five stars in together, and the other one is basically a subgiant star. This star system is found in the belt of the Orion. Like if you look at the Orion constellation, the belt part, the westernmost star in the belt part of the Orion is what we call as the Mintaka. Its other name is actually Delta Orionis. So in many places, you will not see the name Mintaka, you will see Delta Orionis. So if you're seeing the word Delta Orionis, know that we are talking about Mintaka in there. So if you look into the star, it's basically a multiple star system and it's basically 1300 light years away from us. So this star is basically around 1200 light years away from us. This star is basically 1200 light years away from us, and the stars they are separated from each other with an orbit that takes them around 400 years. So, interestingly, if I zoom this image now, the separation between both the stars is basically you're just 0.26 arc seconds, but that separation is actually so large that for taking one revolution around the bigger giant, the subgiant star takes around 400 years. So, in cosmic scale, when you see something like this, the distance doesn't feel large at all. But when you understand, when you see how large it is, you will be absolutely mesmerized with the beauty of it, that you are seeing this in such a small image, and we understand how small and how inconvenient we are compared to the whole grand cosmos. So this star is what we call as the Mintaka. Since we are also talking about Orion in here, let me also tell you, Orion is one of the most beautiful constellations you will ever see because it has several different kind of binary stars and various deep space objects will be there. Horsehead Nebula, Orion Nebula, then the Trapezium star cluster, and Monkey Head Nebula. There are many beautiful deep space objects in there. So after binary star of Mintaka, uh, my next image is Alcor and Mizar. This star is what we call as Alcor and Mizar. This was the star that I was talking about in the Big Dipper. This star is located around 100 light years away from us. So, on cosmic terms, if we say it's not too far away from us, 100 light years is very less on a cosmic scale. The Indian name of these two stars is Vasishtha and Arundhati. And the interesting thing is, if you look that between these two bright stars, at this in between them, there is another star that I have shown it with an arrow in here. This star is called Sidus Ludoviciana. Sidus Ludoviciana looks like it is all three are together, but it's not. Alcor and Mizar is just 100 light years away from us, but Sidus Ludoviciana is around 300 light years away from us. So basically, it's three times more distant from us than Alcor and Mizar. But often, what we see is, on an optical point of view, we see all the three stars together. But that is what we often say that light is relative in this case, because what we see it can be deceiving in astronomy. So what we see here is three stars forming a triangle kind of a structure, but in reality, the third star, the star in between them, is actually much far away, nearly three times more far away than the other two stars. Uh, Now I'll go to some deep space objects that we have done, that we have photographed using our smart telescope. This is Horsehead Nebula. We pictured this Horsehead Nebula around, like, we pictured this around last year in December, and we gave this a data of around 1 hour. So what a smart telescope does is it takes one picture, one after other. It takes several pictures and then it stacks it. It stacks all those images together and gives you a data of 1 hour, 2 hour, of whatever time you want to take pictures of. So that is how we get so beautiful deep space images. even from the city areas. I took this picture from Kolkata, and you can understand this that Kolkata is basically a bottle line sky. And I took this picture from there. The only editing that was done on this, I did not use any kind of editing softwares like PixInsight or Cyril or Star Exterminator. I used nothing. I only used Adobe Lightroom, a little bit of Adobe Lightroom to get all this picture together. So this is what you can get even from the city skies. This is Horsehead Nebula. It is located around 1,310 light years away from us. And it's one of the star forming regions of Orion. Like I was saying before, that how Orion is a very interesting constellation. There are several deep space objects in there, and one of them is Horsehead Nebula. That beautiful pinkish red glow that you are getting, this is because of a rapid amount of star birth that is happening in this nebula. And those newborn stars, they are radiating a lot of ultraviolet radiation, and this UV light is causing the hydrogen cloud, the ionized hydrogen cloud, to glow red. And this is why we are getting this beautiful reddish color, this reddish tinge of the Horsehead Nebula. Uh, Another thing about Horsehead Nebula, if you see, is the head of the horse that you are seeing here. I'll zoom the image for every one of you. The head of the horse, its radius is around 3 light years. So what you're seeing is basically 3 light years out there. Um, and 3 light years is a extremely huge number, because we haven't been able to get even our uh, spacecrafts like Voyager and all in 1 light year so far in 50 years. So you can understand that how large it actually is. So this is Horsehead Nebula. This is what we pictured last year. I'll show the next one. This is Dumbbell Nebula. I captured this image just 3 or 4 nights back. This is a planetary nebula. I'll zoom this for every one of you to see, or if anyone wants to take picture, you can. This is a planetary nebula. Now, what happens when a star like our sun, which are what we consider as medium and low mass stars, when a star like sun, it extinguishes all of its hydrogen and helium fuel, it goes into a rapid expansion mode and it becomes a giant. And after it becomes a giant, what happens is the radiation pressure uh, becomes greater than the gravitational pull of the star. There is two different forces that is acting upon a star. A star is basically a balancing act between two forces. One force is a gravitational force, which is trying to compress the star into its own core. When gravitational force wins, star goes into supernova mode. Supernova happens, and when the radiation pressure of the star wins, what happens is star slowly blows off its whole atmosphere. It blows off its surface in a stellar wind, which we call as the planetary nebula. It forms a planetary nebula this way. So what you're seeing is basically ionized hydrogen and ionized oxygen in here, and that is forming this planetary nebula. Now, what is happening is why it's glowing red? Because when the hydrogen gas cloud that came out from the star is expanding into the interstellar space medium, slowly it's getting ionized. And when it's getting ionized, it's glowing very hot with a red color tinge in it. And this is why you're getting that red color tinge outside of this planetary nebula. Understand this? That the mass that our sun has, 5 to 6 billion years from now, our sun will also end up its life in something like this. So, so just imagine, like 6 or 7 billion years from now, maybe intelligent civilization, 100 light years away from us, if they look into this part of the night sky with their telescope, they will never have a clue that once life existed here, that once Earth was here. This is what the cosmic scale of life cycle of stars are. So this is what we call as the Dumbbell Nebula. Its Messier name is Messier 27. Its distance is around 1360 light years away from us. The star at the center of this nebula is one of the largest known white dwarfs we can ever see. I don't know if you will be able to see the star at its center. I will try to zoom it. At the center, which is very faint and getting a little bit pixelated in here, you can see there is a white dot kind of thing. That small white dot that you are seeing, that's one of the massive white dwarfs that we have seen so far. White dwarfs are basically very faint. It's very, very faint and it's not much visible at all. But this is one of the largest and one of the most massive white dwarfs that we know so far. Okay. Uh, the radius of this whole nebula is around 1.44 light years. And we expect this nebula formed around 9,800 years ago. So basically, the age of the nebula is around 9,800 years. The expansion of the gas clouds that is taking place in this nebula is around 31 kilometers per second. So basically, it's expanding 31 kilometers every second. So this is your dumbbell nebula. We took this picture just a couple of days back. If you have a telescope, a smart telescope, or even a very or a binocular, you will be able to see this nebula in the constellation of Vulpecula. In the Vulpecula constellation, you will be able to see this nebula very well. It's quite bright. This is a star cluster, what we call as the double Perseus double star cluster. We captured this image a few months back. This is a beautiful star cluster and it looks absolutely fabulous. When you take the star cluster, even in a Dobsonian scope or even in a binoculars from city sky, you will be able to see this star cluster. It is located in the Perseus constellation. This is what we call as a double star cluster because if you see, there are two different star clusters in here. They are at a diagonal away from each other, at a diagonals. The upper one is what we call as NGC 869 and the lower one is what we call as the NGC 884. The age of both of this cluster is around 12.8 million years and its distance is around 7,500 light years away from us. So what you are looking at is basically the stars that are 7,500 light years away from us. It is blue shifting to us at 21 miles per second. I don't know if any one of you are I'm sure that most of you will know the concept of blue shift and red shift, but still I will say this for any students who are here. What happens is the space is rapidly expanding, and when the space is expanding, the light that is coming from an object, from a distant object towards us, what happens is the wavelength of that light it gets expanded too, and when that happens, in spectrum, sorry, let me just get some water. So when that happens, from time to time in the spectrum you will see, in the spectroscopy you will see that it's moving towards the red spectrum area. That is what we call as the red shift. It means that the space is expanding and the object is basically going away from us. But when the object is coming towards us, the light slowly moves towards the blue side of the spectrum, and that is what we call as the blue shift. So what we know is that this star cluster is coming towards us. It's coming near to Earth. And possibly in a few thousand years, it will be a little bit much more closer to us than what it is now. So this is your Perseus double cluster. If you want to find it, you can see it in the Perseus constellation. Okay. This is Helix Nebula. Other name of this nebula is basically Eye of God. Its name is NGC 7293. This nebula is located just 655 light years away from us. This is also a planetary nebula. The gas cloud here after the planetary nebula, in case of a planetary nebula, the gas cloud here is also expanding. The reason why it's expanding because this whole nebula incident, it happened around 10,000 years ago, and now the gas cloud is slowly expanding with that. If we look at this nebula, maybe 10,000 or 12,000 years later, we will see it has expanded more. Its expansion rate is around 40 kilometers per second. 40 kilometers per second, that is the speed at which the gas cloud is expanding. Uh, so this is your Helix Nebula. Now, after this, this is the comet that we captured just 2 nights ago. I haven't given much details about this comet because it's just discovered, and as far as I know, that comet A6 Limons, it has an orbital period of around 1,350 years. So next, it will return around 12 to 1,300 years later. It will return back. This comet might be visible later this month with naked eyes from a little suburban city skies. It might be visible, but we took this 2 nights ago in our telescope, smart telescope actually, and you can see that it's slowly forming a tail structure. It hasn't formed the proper tail yet. We believe that in next 15 to 20 days, the proper tail of this comet will come because it's going more closer and closer towards the sun. It hasn't gone way too close towards the sun yet. It will go more closer, and when it will get more closer to the sun, we believe that it will become more brighter. Might be even visible with the naked eyes also. So this is your comet A6 Limons. By the way, for every one of you, I should also say this that by the end of this month, by the end of October, two more comets will be visible. One is the Swan comet, Swan R2, that will be visible, and the other one is the K1 Atlas. Both the comets will be visible, but at the very southwestern skies. Just after the sunset, towards the southwestern sky, you will be able to find these two comets. Uh, Now, the next part is this is the Eastern Veil Nebula. This is basically a supernova remnant. Towards the beginning of this presentation, I talked about how some stars, the massive stars, they go into supernova mode. So when the supernova explosion happens, it blows away all of its whole. The star blows itself apart completely, and when the star is blowing itself apart completely, the gas that remains of this, it forms structures like nebula, what we call as the supernova remnant. So this is a supernova remnant. Its distance is around 2,000 light years away from us. The radius is around 110 light years across. From up to down, this is around 110 light years across. The age of this nebula is around 10,000 years, and it is born out of a very massive supernova explosion. This was captured by us like 1 or 2 months back. We captured it around midnight. I generally do most of my astrophotography after midnight so that I can get a very proper night sky for the views. Now, I think you all know about Orion. This is Orion Nebula M42 that we know of. Its distance is around 1344 light years, and its radius is around 13 light years. The whole radius that you see is around 13 light years, and it's a massive star forming region. Actually, if I zoom this image, I'll show you something. At the core of this, you can see it's extremely bright, and you can barely see anything at its core. The core of this whole nebula is shining so bright because it's a place where there is a rapid amount of star formation is happening. And because of this hot newborn young stars, the whole nebula is glowing so brightly. Uh, a lot of star formation is taking place. And also one another important thing for especially when we talk about the chemistry part of astrophysics in here, this nebula has a huge content of water molecules in it. So we can just see this that if a planet is forming in one of those stars in here, that planet might have water in it. There is a chance, there is a very small probable chance, but there is a chance that it might also get water in it because this nebula contains a lot of water and also a lot of ethanol content in it. Uh, so after Orion Nebula, uh, I will be ending my presentation with this slide. There is a few things that you must remember when you are doing night sky observation from the city light areas. First is try to get the objects which has a magnitude less than plus 10. The objects with a magnitude more than plus 10 will become very faint, and you might not also get them in your telescope or even in your smart telescopes also very well. So to properly get any kind of objects for viewing in your smart telescopes, the best will be to get objects that are less than plus 10 in its magnitude. The next is for planetary viewing purposes, Dobsonian scopes are best. Smart telescopes are not what we use for planetary purpose. For planetary visions, Dobson scopes are the best one. You will be able to get a very proper view of Saturn, Jupiter, Mars with the help of an 8-inch or a 12-inch Dobsonian scope. This thing is very important to remember. Remember this, that you won't be able to get a night sky of the Bottle 1 night sky. Bottle 1 night sky is a completely light pollution free night sky, and you won't get that in a city sky. But you will at least get something. You will at least get some of the things that you can see. And like I always say this, that it's better to have something. It's much better than having nothing at all. Be calm and patient. When you are trying to do astrophotography or when you are trying to do visual astronomy from the city night sky, be calm and be patient. Understand this, that it takes time. It takes time, it takes a lot of practice. You'll have to be patient and you will have to be a lot calm and you will have to practice more. You will not be able to set your telescope properly on the very first day. You will not be able to adjust the focus very properly on your very first day. It takes practice. Don't give up. Don't give up. Keep practicing. Keep trying. Be patient, and slowly you will get it. So with this, I'm ending my presentation. I hope every one of you liked it. So thank you, everyone.
Thank you so much, sir. This was really in this session. Your words have not only introduced us to techniques of astrophotography, but also inspire us to look at the sky with new curiosity and passion. Now we are open for a few question and answer. If anybody have any question.
Yes, Dr. Chakraborty, it was an awesome talk. Thank you for it. I have a small question that how we estimate the signatures originated from different nebulas for different organic material or water or etc.
Actually, what happens is there is something called emission spectrum. Emission spectrum and absorption spectrum. Let me explain that to you this way. We know that light is basically photon particles. Now, what happens is every element that we know, from hydrogen to every other element that exists in the universe, every of these elements have different kind of a atomic combination, atomic structure in it. Now, what happens is every of this element absorbs a certain bit of photons from the light. So now when a light from, suppose a star is coming, like suppose we are getting the light from the sun. So when we are putting the light of the sun in a spectrum, we get a emission spectrum there. We see a lot of black lines in there, a lot of black lines, and those black lines are what we call as the absorption lines. And when we see those black lines, with those black lines, we can see like which elements are there, like which elements are present in that star. because those elements are absorbing those photons from the light, and hence you're getting those black small bar kind of structures. Now we really don't know like how to do it, but scientists, what they do is they know like which lines are for which kind of elements, and with that they are able to track like which kind of elements or which kind of compounds are there in that star. So like suppose you want to know the chemical composition of Orion Nebula, what has to be done is the light from Orion Nebula has to be put into a spectrometer. Into a spectrometer. Now, in the spectrometer, you are getting the spectrum. Now, if you see that spectrum, you will see the small lines which will give you a hint of what kind of elements are there in that nebula. So, with this way, we actually find the different compositions. Like even when we are looking for life elsewhere, one of the way that we are doing it is we are trying to get the light from the exoplanets. Like when you're getting that spectrum line from the exoplanets, reading those lines, we will be able to decode if there is any life or not. Like to understand if there is a intelligent civilization there or not in a planet, we will often track for the signatures of carbon dioxide and carbon monoxide, because generally carbon monoxide is something that we often get from artificial kind of pollutants. So we will look for those kind of gases to see if there is any life possible or not. We will obviously see for things like oxygen and all, which is there, but we will also look for these kind of things. So this is how it is done. Okay.
Okay.
Any more questions?
Gaurav,
Thank you.
Sir, how we get to know the distance between star and us?
There is a method called parallax, which where we use the trigonometric angles between two different locations of the Earth. Like suppose I'm standing in India right now, and I'm looking at a star, suppose at an angle of 30 degrees, and you are looking at the same star, but from somewhere else, like maybe suppose 3,000 or 4,000 kilometers away from me, and you are looking at that star, and you are getting at another angle. Like suppose you are getting an angle of 60 degrees. So now when we compare all of this three, it's forming a triangle kind of a structure. With the help of the trigonometric angles in here, with the trigonometric ratios, we can find approximate distance of the star. It's not, I won't say that parallax is the is the best way, but it's a way with which we can get a proper distance of the star. Next question.
So I had a question. Recently, on the Martian flight, we discovered an object called 3I Atlas, which is said to be an interstellar object or an alien spacecraft. So, is it really an interstellar or alien spacecraft which has entered the solar system, or is it just a passerby asteroid as we have observed in the many years?
Actually, see, generally what happens is in every kind of tabloids and every kind of internet mediums, you will see that someone has said that it's a alien thing, it's alien spacecraft. This no, it's not. It's just a natural object. It has been pictured by NASA itself, and we have found a very proper coma of that comet. So we now know this that it's a natural object. It's not any kind of artificial object. Yeah, what might have happened is this that it might be a extraterrestrial. It's a outer solar kind of a comet, you can say, like which has come from possibly some other solar system, from other stars or something. But no, it's not any kind of alien thing. So no, it's not any aliens or nothing. It has a proper coma. It has a very proper coma, so which shows this that it's just a comet and nothing else.
And so, what about the objects like Hope, which we have discovered in the last 5 years?
Uh, can you be a little more? I mean, I wasn't able to hear your question.
I'll write it in the chat.
Which one? Hello. Can you tell me your question? Okay.
sir, he has written in the chat.
Yeah.
So,
I saw it now. See, even for the Oumuamua, I would say this that it was basically a comet. It was possibly a asteroid that came from some other solar system. It was not any kind of an artificial object. There are certain few things that you have to see. Like when you're trying to see if anything is artificial or not, you'll have to depend on certain few signatures, certain few traces, and everything that we have checked with that the scientists have checked with that object, nothing showed this that it could be an artificial. It was generally a natural object, but it was at such a huge speed because possibly it crossed very massive object somewhere, which gave it a very strong gravitational slingshot, and that's why it's accelerating so fast, and it accelerated so rapidly from our solar system. So no, I don't think it was any kind of a artificial system. It was a natural one.
Victor, my
Next.
last question is related to today's topic that what should be the camera setting for getting Da Vinci light or earth shine light of the moon in crescent and gibbous form?
I'll be honest to you on this one. You won't be able to get that from city lights. You won't be able to. What you have to do is you will have to go to a bottle 3 or bottle 4 night sky. A bottle 3, bottle 4 night sky will give you a very proper view of that. And as far as I know, for getting the earth shine and the Gegenschein, actually, you'll have to get something around ISO will be in a darker skies. ISO will be something around 600. When you're going to a very dark sky, you have to increase the ISO a little bit, and the shutter speed will have to be something around uh, 10 to 15 seconds approximately from those areas. You might be able to get that from there. It's a very rare thing to see. I mean, I know only of very few astronomers myself who has seen that, and who have seen that from a location around West Bengal called Mednipur, which has very much dark skies in there, and they were able to find it from there. This is what I'm talking about, like 30 years back. They were able to get it. So I think you will be able to get the earth shine and the Gegenschein from something around from a very darker sky locations.
Thank you.
Akshay, do you want to ask certain question, any question?
Yes, ma'am.
Yes, you can ask.
Sir, we can see the planet by mobile.
You can definitely see the planet with your phone, but the point is you will only see it like a star, like a small star and nothing else. You will definitely need a telescope to see a planet. With phone, you won't be able to see the planet.
Sir, we have to buy.
Yeah, obviously. Then you will have to buy a telescope to see the planet properly. Like if you want to see, suppose you want to see Jupiter, so you want to see the red spot of the Jupiter or the clouds of the Jupiter or the moons of the Jupiter, you will definitely need a telescope. You won't be able to get that with a phone or a telescope. Or sometimes what happens is with very like wildlife photography cameras that many people have. With that, you might be able to get the moons of Jupiter. But generally, with phone, no, you can't.
Okay, sir.
Any more questions? So now I request Sharon Pantavne, student of BSc first year physics, to propose formal vote of thanks. Sharon, are you there?
Yes, I am there. I hope I'm audible to everybody.
Yes.
Okay. What a wonderful talk this has been. I really am honored to extend the vote of thanks to all of you present here today. Let's start with our keynote speaker, Dr. Victor Chakraborty, for giving us a wonderful presentation. It was very, very detailed, and I really hope that his expertise is going to help us all. My thanks also to Captain Dr. Prashant Ambekar sir, the head of Department of Physics and the vice principal of Dharampet MP Memorial Science College, who has allowed us to be a part of the National Network of Astronomy. My thank you to also Dr. P.K. Ahluwalia, who has opened the doors of NASNI to college students like us, as well as Dr. Hemant Kumar sir, the national coordinator of NASNI, who has actually allowed us to be a part of the grand network of NASNI. Lastly, my thanks to all the participants present here today who have participated very enthusiastically in this talk. So once again, thank you.